This is Team Pineapple's Python project. Our team members are Andrew, Duncan, Pratyush, and myself, Bill. So starting off with an overview of the project and our methods. We decided to take user input for the image and thresholding values, as well as call functions that perform the tasks needed for image processing within the main method. The actual image processing methods, grayscaling, blurring, edge enhancement, and thresholding, will be in a separate Python file and will be called from the main file. First, after taking the user input, we call the rescaling function. The rescaling and grayscaling functions are within one Python file, so we just call the grayscaling and rescaling functions with the same Python file. The grayscaling function takes the dimensions as a and b using the image.shape method, and using a and b as the range, we use a nested for loop to populate a new array with the altered RGB values. To find the RGB values, we iterate through the ranges a and b, with those being the first and second dimensions. The third dimensions will be 0, 1, and 2 to correlate to each of the values for each pixel. The altered values will be assigned to a new array, those of which are added up and populated in a new two-dimensional array called Z. When rescaling, we implemented a nested while loop to iterate through each pixel RGB value, so we could resize it to a number between 0 and 255. As for smoothing, we initialize an averaging window with the value 1/9 in a 3x3 grid. We call the window operator function, which uses nested while loops that iterate through every pixel. In the nested while loop, there are multiple if statements to consider the type of pixel, whether that is the corners, sides, or middle pixels. Depending upon that, we customize adding up the multiplied window values for each 3x3 grid corresponding to each pixel in the array. We initialize the new image into a NumPy array and return it. As for edge enhancement, we initialize the Sobel X window and Y window operator arrays in the user-defined edge enhancement function and send them to the same window operator function that was used for smoothing. Once those values are returned, we find the width and height of the X window using image.shape1 and image.shape0. We then initialize the final image array using the width and height and convert it to float using NumPy functions. Then we iterate through nested while loops to calculate the magnitude of the gradient of each pixel. We use these values to populate the edge enhanced image array, which is then returned. Just like all the other parts of the code, the thresholding function is called through the main Python file. The thresholding function takes in the edge enhanced image and the thresholding value as parameters and iterates through every pixel in the edge enhanced image. If the pixel value is less than the thresholding value, it is equated to 1. Otherwise, it's equated to 255. The image is returned. All right, so now we're going to demonstrate our code using two different images. So first, we're going to input the name of the file that we want to process. We're going to be using the coins picture. And then we're going to enter the threshold value for that picture. Then we wait for the code to run. And then the process picture shows up in the plots area of the spider window. So we're going to do the same thing again with another picture. And that picture is going to be of the Purdue Arch. So once again, we enter the name of the file and then enter the thresholding value. And we wait for the code to run. And then once again, it shows up in the plot section of the spider window. And now we're going to test the error detection. And so for the error detection, we're going to enter just another file. But for the thresholding, we're going to enter a number that's either less than 0 or greater than 255. And what happens then is that it's going to prompt the user to put in a value that actually works with our function, like 255. All right, there we go.